As we continue with Chapter 4 about inverse functions, we will be looking at Lesson 4.6, which is logarithmic functions, which we will find they are the inverse of exponential functions. So our objectives for today is we're going to graph the inverse of exponential functions, which again will be logarithmic functions, and we'll be converting between forms. So we will jump right in. Here we have the graph of y equals 2 to the x. So it says graph the inverse. Well, we know when we graph an inverse that we switch the x values and the y values. So each point that's on this blue y equals 2 to the x graph, if we switch the x value and y value, that will give us the inverse. So what we'll do is we'll just pick a few points that can help us, and we'll talk through some ideas. So on y equals 2 to the x, here at this x I just put in here, that is negative 1, 1/2. So this is negative 1, 1/2. So we want to make sure we graph 1/2, negative 1. So 1/2, negative 1. So that one goes to that. And then the next one, this is the point 0, 1. And so we want to graph 1, 0. The next one, we have 1, 2. So we will graph the point 2, 1. And we actually have one more point up here. We have the point 2, 4. So the inverse of that is 4, 2. Another thing here that we talked about, since the x-axis is a horizontal asymptote, the y-axis will be a vertical asymptote. So we can sketch the graph of the inverse, and it would look like this. And so that's the basic graph of what will be called a logarithmic function. And while we're at it, just to review, when we graphed exponential functions, to help us, we graphed the point 1b, so 1 the base, whatever the base is. In the case we just did was 2. We always had the point 0, 1, and then we had negative 1, 1 over b, which really just means the reciprocal of the base. So when we graph the inverse, which are logarithmic functions, we're going to graph the point b1, which is the base 1, the point 1, 0, and the point 1 over b, negative 1, which again, 1 over b is the reciprocal of the base. And so that can be three key points that help us. And then the last thing, with exponential functions, we knew that the x-axis was a horizontal asymptote. And so for logarithmic functions, the y-axis is a vertical asymptote. So those are some keys to remember when graphing logarithmic functions. So logarithmic function, down in the next section here, f of x or y equals log base a of x, where a has to be greater than 0. So you never have a base that's negative. A doesn't equal 1, because if a was 1, it would just be a constant function, and x has to be greater than or equal to 0. So we don't put negatives in here either. It's the inverse of the exponential function, f of x equals a to the x. So notice the base, let's use a highlighter, the base of the logarithm, which was a, is the base of the exponent when we talk about the reciprocals. not reciprocals, inverses. This is really important here, this next part. Equations can be changed from logarithmic form to exponential form and vice versa. And here's what we remember. If we have y equals log base a of x, that's the same concept as a to the y equals x. And this has one arrow here, but I'm going to go ahead and change this and can put both arrows because it says vice versa. So we can, this is what we use for converting from one form to another. Sometimes it's helpful to have an equation in logarithmic form, and sometimes it's helpful to have an equation in exponential form. So we just have two examples here, but this is really important. So we'll have several questions like this in our assignment. So write log base 4 of 64 equals y in exponential form. And again, that's how you say it, log base 4 of 64 equals y. And we want to put that in exponential form. One thing that helps me is the base of the logarithm is the base of the exponent. So we have 4 is our base, 4 to the y power equals 64. It didn't ask us to find any values, it just asked us to switch forms. So that would be your answer there. Over here, wants us to go the other way. We have exponential form and we want to switch to logarithmic form. So once again, before I said the base of the logarithm is the base of the exponent. And so the base of the exponent, 3, is going to be the base of our logarithm. So log base 3 of 1 over 243 is equal to negative 5. Again, you'll be doing several questions where you're going to be converting. The next one says prove log base a of 1 equals 0 for a is greater than 0 with a not equaling 1. So that refers back to our stipulations for logarithms before. The proof really isn't that long or much of a proof. If we think of this in exponential form, this would be a to the 0 equals 1, which we know is true previously when we had our rules of exponents. So a to the 0 equals 1, just changing forms shows us that that original statement is true. And then the last thing we're going to mention is just a couple special logarithms. These are ones that occur often when we work with things in math. And so first we have common logarithms, and that's a logarithm with a base of 10. So base 10, that's what we deal with, a base 10 system. We have 10 digits, 0 through 9, so that's why that one is very familiar. The base of a common log is not usually written, so in the equation, log of 100 equals 2. Notice there's no base written here, but when there's no base written, we assume it's base 10. It's very similar to the idea of like when we write something like this, we say that's equal to 2. Well, that's just a radical, and it's an understood 2. It's an understood square root. Well, the same idea if we have a log with no base written, it's understood. 10 common logs can be found using a calculator. There's just a button that has it. Usually it's in all caps, L-O-G, log button. And then we talk about natural logarithms. And a logarithm with a base of the natural number e. So we represent that with a lowercase e, which we'll talk about in a minute here. The base of the natural log is not usually written. We use the abbreviation ln. Actually, when we write it, we don't usually capitalize it. We usually just write ln. So natural log to indicate natural log. So log base e of 7 is the same as ln of 7. So you can think logarithm natural is why it's ln. And instead of writing log base e, that occurs so many times, we just have a shorthand for it where we just write ln instead of log base e. And same idea with calculators. You can look for a button on your calculator, and again, I think it's usually in caps, but it's ln button, natural log. So there's a couple examples here. So what we're going to do is just use this. It says use a calculator. Here's just one that I have on here. The first one says find, and it says log, so log of 48. No base is written. That means it's a base 10, but right there is your log button, log base 10. So all we do is we type, click that button and put in 48, and that is 1.68. And obviously it has more there that's approximately equal to that. So please remember, so actually that's how you find it. I shouldn't say please remember, but just to let you know, that means that 10, because that's our log, our base, to the 1.68 is equal to 48. That's what that means when we get an answer of 1.68. Next one, find natural log of 48. Well, natural log, that button's right below it. So we're going to hit natural log 48, and we hit that, and that is 3.87, approximately 3.87. And that's it. This was just an introduction of logarithms. So there's lesson 4.6.